How do? It's been a spell, but we've been busy, and got to get a little caught up on a few things here, including we survived. We survived. We had that asteroid that was predicted mathematically to miss us by a quarter of the distance between us and the moon, which is really close. Now, this thing was, of course, reported to be larger than the size of a bus, which would have made a big boom. So, luckily for us, it went right on by. It missed us. Whoop. So, we're alive. We're good. We survived yesterday. Well, it came by yesterday morning, this being May 19th, 2026. I had to check what day it was. Anyways, it's good news. We survived it. Obviously. Then we also have another news coming in. Let me get that right there. There we go. Our sun is still remaining to be very busy. Now, I haven't been giving you updates on the tantrums it's been throwing of late because, like I said before, I'd be reporting every day. It's been throwing across the spectrum at us, gives us a couple of days of rest, and then it fires back up again. And as you can see here, these ridges, those are openings. That's where the solar wind comes from. And these over here are CMEs going off. Those are boom. And meanwhile, the Earth is about the size of my finger, actually, even substantially less than the tip of my finger. But anyhow, we had some radio disturbances. We've had some nice aurora borealises. If you are up north high enough, which again, good for you. Lucky. The weather was probably good for you. And it's going to continue this way for a while. Sun doesn't want to go quiet, and that's good. Well, potentially good, because we've also been seeing a hell of a lot of earthquakes going off, and we've got volcanoes tripping. So, are they related? An absolute coincidence? And the sun is suddenly really busy, and each time the sun gets really busy and sends some good old energy and juice in our direction, we get very large earthquakes, and we're getting volcanoes and some interesting storms. So I think at this point, I'm saying they're related. I'm going to say they're absolutely. I'm going to go for it. They're related. Cause and causality. Well, I'm thinking we got just cause, Your Honor, just cause. And this brings us to another potential issue, though. Allow me to give us another demonstration. Now, again, this is nice little image, not as good as my colorful one here, or vice versa, depending on your opinion. Anyways, as you can see, Earth has, as you know, Earth has a north and south pole, and so does our magnetic field. Our magnetic field shields are also with a north and south pole, and it has its rays that are protecting us from the energy from the sun. And as you can see with the sun, with the energy of the sun, it kind of bends our shields, and it's fluctuating towards the back, and they're kind of like blowing off in the opposite direction of the sun. Our shields are buckling, Captain, which is quite true. And also currently, with our shields being under a lot of pressure, a lot of energy coming at it because the sun's being so happy and doing everything it's doing, letting us know it's there every day, and really letting us know it's there every day by, again, with its CMEs and its solar winds and its radiation. Don't worry. But hang on. Don't worry just yet. Don't worry just yet. People were wondering, because we, as people, the activity going on with earthquakes all around the world, and a lot of them, and they're big. And we got volcanoes waking up, active volcanoes being more active, inactive volcanoes becoming active. So that makes people think that, there's our iron core and the fluids going around inside our Earth, the iron core. That's what, makes our wonderful shields that protect us, just like a battery. Just like a battery. Ta-da, a battery. So this is going to be our high-tech model here, and I know we waste no money on our budget here. Absolutely, we got a huge limit on our, a huge limit, a lack of limit. But anyways, I'm going to use this battery. Try to use this battery as an example. Okay, so our battery has a north and south pole, and fields come off of it, fields come off of it, fields come off of it, just like as seen above. Okay, and the weak point is at the top and at the bottom, as viewed above. See, we got the little gaps. That's where the fields come and go from. Okay, now north south, north pole, south pole. If it flips, it flips. Okay, yes, we can deal with now north being south and south being north. That's going to be okay. We can handle that. That's things are just be pointing a little different. All right. The problem is when it flips and how long it takes to flip, because those points, north and south, or south and north, space is relevant, the dipoles are the weakest point of our shield, because that's where it's coming in and coming out of. Okay, hence the aurora borealis, which is energy being taken from our shield scaffold and being diverted in, and that's what causes it. That's all solar energy coming at us. And luckily, we have those pointing away from the sun, and our shields are taking it, and the energy is flowing over, and as you can see, it gets pushed by the wind as well. So again, we have a weak point here and a weak point here. Now, as the Earth flips its dipole, so north goes to north and south goes to south, the magnetic field flips. As it flips, if it's pointing towards the sun, when it flips over, all that solar energy is coming in when we don't have shields. Shields are down, Captain. That means anything in the path as it flips, as the day turns, as it flips from north to south, whatever's in that pattern, that round object that is going to be going up, up and down our planet. It is going to mess with electronics. It's going to mess with satellites. It's going to be a mess, and our power system is going to go. It's going to know what to do. We're all going to get a suntan a little better. We're going to be getting a lot more UV rays coming in, solar energy, solar particles, the whole 9 yards. So, if it flips kind of quickly, we're okay. If it flips slowly, we're in a bit of trouble, especially with our sun going off as much as it has. And again, last time it did a full flip was 780,000 years ago. And then about half the time, halfway between, a little over, about 450,000 years ago, all right, a little less, it did a little bit of a flip and then came back, as I mentioned earlier. That's even, that's dangerous too. Like a little flip going over and then come back, you're getting double whammies. So, ow, ow, ow. Is it going to happen? Oh, yeah, it's going to happen eventually. It happened before, and it's happened before, and it's almost happened recently, relatively. Is it going to flip? I don't think so. Not currently. Next year, no. Next couple of years, no. The only thing we can hope for is when it does flip, hopefully it'll be like 11 years from now, as it were, because when the sun's out of its active period and becomes more dormant, and it's not doing so much. Not so many sunspots, not so many CMEs. The solar wind is a little bit, it cools off. It's sitting in the corner for a while, behaving itself, as opposed to running around like a child full of sugar right now. So, Dooch new. Am I going to lose sleep over it? Nah. But anyways, we've had some interesting things going on, and I apologize for not getting out and giving more news more often. Issues, life happening in between, and more hard drive problems. But anyways, I'll try to get some more out more frequently. And yeah. So we'll just call it a day, and Savos. There's a button over here. We're out.